Hi, I'm Eva Johanna Veik, a project manager at Positium. Today I will tell you a bit about the dashboard we have developed within the European Commission's Builders project. The dashboard aims to enhance the crisis management processes by using historical mobile positioning data. Positium analyzes mobile positioning data from mobile network operators and creates official statistics for population, tourism, and mobility studies. For nearly 2 decades, we have been developing the best methodologies and algorithms in close collaboration with the University of Tartu and validating results to ensure the highest quality statistics. Today, mobile phones are widely used everywhere. Every time a call is made, an SMS is sent, or mobile internet is used, a row in mobile network operators database is saved saying that this SIM card connected to this cell tower on this day at this time. Positium uses this data in anonymous form for creating official statistics. In Positium's context, we are talking about passive mobile positioning data. This means that we calculate people's whereabouts based on cell towers coverage areas. It is not based on GPS nor satellite data. We use this data from mobile network operator and add cell towers coverage areas as reference data and calculate based on this in which area the subscriber was during the event of a call, SMS, or mobile internet usage. As the first step, Positium cleans the data from duplicates, errors, and all other abnormalities big databases might have. We also remove machines that use SIM cards, like security cameras. Then we calculate each subscriber's anchor points. These are the places the subscriber visits regularly, like home, work, and other regularly visited places. And based on this, we are able to create each subscriber's pipeline of whereabouts and movements. Then these results are aggregated to general results, saying on this day there were so many people in location A who live there, or there were so many people on that day who moved from point A to point B. All of the data on the dashboard is anonymous. When Positium gets the data from the mobile network operator, all user IDs are pseudonymized to a different code that only the mobile network operator itself is able to unlock. The data is also cleansed, used in calculations, the results are aggregated and generalized to the whole population by coefficients, making sure that individuals cannot be tracked. Also, all results below 10 are not shown. Positium has built a dashboard based on mobile positioning data that shows subscriber counts throughout the year 2019 in 3 types of settlement units of different sizes. We have county, municipality, and village, and also in daily and hourly view. The dashboard has 3 layers: population statistics, origin-destination matrices, and secondary homes. The first, population statistics layer, is for you to see how many and what subscriber groups are usually in the area during the chosen time frame. User can distinguish between 6 different population groups based on their usual mobility patterns and whereabouts. The indicator place of residence shows people living in the area. Work shows the number of people working in the area. Regular visitors are people visiting the area often, for example, for going to the gym or to the shops. Also transit travelers, foreign tourists in Estonia, and also domestic tourists, meaning Estonians in Estonia, can be distinguished. Users are able to see hourly, daily, weekly, and seasonal subscriber count patterns. Here you can see the fluctuation in the number of subscribers present in one area, depending on the day of the week. Note that there are much more people present during the day compared to the night, and that the counts drop for Saturday and even more for Sunday. It makes a big difference in resources needs during different times of day and on different days. Here you can see a drop in subscriber counts at the end of June. This is caused by a national holiday in Estonia, where majority of people drive to countryside. The peak right after this is the Estonian Song Festival, where domestic tourism rose significantly due to Estonians going to Tallinn to the concert. The drop at the end of year is also caused by holidays when people usually drive to countrysides. This layer enables rescuers to do more exact risk evaluations for buildings and hazard areas, as the risk level changes throughout the day, within the week, and depending on the season. It is not a static value anymore. It helps to identify different groups which have different kind of behavior in crisis situation, and to decide how to respond to each one of them. This layer also helps to estimate how many people were out of electricity during the crisis. Here you can see a drastic drop in subscriber counts from 5 p.m. And when you look at the nearby areas, the number goes significantly up. This does not mean that people started suddenly moving out of the area, but it indicates that the cell towers within the area went down and people started to connect to cell towers from nearby areas. This makes it seemingly look as if people are moving out, but it actually shows when cell towers went offline, when they were back online, and it is possible to estimate how many people were without connection. The second layer, origin-destination matrices, is for you to see how many movements and in which directions usually occur. The user is able to choose between county, municipality, and village as the area sizes, and between daily and hourly mobility patterns. Not only can the user see from where and to where movements take place, but also how many subscribers have moved. This layer can be used to prioritize which roads to block first, or to estimate the amount of resources needed in different scenarios. The secondary homes layer is meant for evacuation planning purposes. In this layer, the user can see how many subscribers would have either a primary or a secondary home as an evacuation location, and would not need evacuation location provided by the state. The user is able to see how many people were in the chosen area during the chosen day, and how many of them can go back to their primary home, meaning that they do not live inside this area, and how many of them can go to a secondary home if their primary home is inside the area and they have a secondary home existent. If these people are deducted from the total, the ones left are the ones that would need evacuation accommodation provided by the state. Here you can see that there are around 103,000 people in the chosen area, and 26% of them can evacuate to their primary home, and 11% can go to their secondary home. This means that out of these 103,000 people, around 37% would not need accommodation provided by the state, as they have a primary or a secondary home to go to. User can also see how far away the evacuation location is from the chosen area. The dashboard currently consists of historical data from 2019, and it can be used to take a retrospective look at the events to analyze how different events change people's regular behavior. The dashboard helps not only to analyze the behavior before, during, and after previous storms and power outages, but also to analyze peak events and gatherings. This dashboard makes it possible to see how many people were in different areas at different times, and how the count has changed during disasters. It is also possible to analyze their movements, directions, and volumes. With this knowledge, it is possible to plan more exactly how many technical and human resources are needed, and how to hinder movements into the crisis area and how to help people out of there. As this dashboard visualizes very clearly how population counts change throughout the day, risk evaluations can be updated as there is no static risk value anymore. It is possible to analyze how warning notifications have changed people's behavior, as you can see hourly movements and changes in population counts. During the validation, we could see the effect of the warning that was given a couple of hours prior to the storm, and how it made people move more than usually. probably to shop for food, bring water, fuel up their vehicles, or to drive out of the soon-to-be crisis area. Also, we could see people coming in from safe areas into the crisis area. We called it the storm tourism, as we know that many photographers wanted to capture the city that was in blackout. As it was unusual, people wanted to witness it and drove into the crisis area, even though it was dangerous. In 2019, there were many big events in Estonia, such as Metallica concert in Tartu, Estonian Song Festival in Tallinn, and international rally event in Saaremaa. Based on mobile positioning data, it is possible to identify from where are people coming from, how long will they stay after the event, when do they go back home, and so on. It is possible to see how many people are in the area during events and to what subscriber groups do they belong to. It is possible to analyze tourists' behavior during big events. From the Metallica concert example, we could see people arrive on the same day, but they did not leave right after the concert. Many of them stayed in the city for a couple of days afterwards as well. End users brought out that as the future events will probably look very similar to these 2019 events, then this information can be used to better regulate traffic based on knowledge of estimated subscriber counts and movements directions. If some cell towers are down, people connect to the cell towers from further away, if possible. Based on this information, it is possible to analyze where the cell towers are down and how long they are down. It makes the dashboard even more reliable if you can see it matching the events you participated in yourself. And the end users confirmed that the hourly view from the mobile positioning data timely matched the real-life events from the storm that we were looking at. The dashboard can be used to update evacuation plans based on the information from the secondary homeless layer. It gives much more accurate input to the shelter planning than has been used until now. Based on this, it is possible to create an evacuation plan not only for accommodation, but also for the evacuation routes so that there would not be any bottlenecks. In case of a crisis where time is short, traffic jams cannot be afforded. During the validation, it was brought out that dangerous materials are being delivered daily through the country. Using the dashboard, they could plan the routes and timing of deliveries to times and locations where the least amount of people are exposed to the danger. If anything should happen to the dangerous materials, the damage would be minimal. A similar approach can be applied for military trainings. They could choose the areas and times for the trainings where the least people are disturbed by the noise or are exposed to certain dangers. From the state security perspective, it was evident that it is important to know, especially in border areas, how many people are there during the day and during the night. As you can see, using mobile positioning data for crisis and disaster management has many benefits. Let's take a step into the future of crisis management together.